This video is for the activity called Can Someone Look That Up? All right, so I'd like you to work on the first page with your groups for about 20 minutes. Okay. And then after those 20 minutes are up, you can go ahead and unpause this video and we'll do the debrief. Okay. All right, so go ahead and start your 20 minutes. And I think we chose number 3 to be the reader earlier. So number 3, you're in charge of reading each question. Okay, so you've been working for 20 minutes. Let's go over the front page of this activity. Okay. So question number 1, we can use the Pythagorean formula to find the missing side. But something I want to highlight here in this first triangle is that for this particular angle, we have the opposite and the adjacent side, which means that we know its tangent ratio. Okay. So we could say the tangent ratio for a 33.7 degree triangle is 2/3. Okay. All right. Now, when we take a look at the second triangle here, right, let's choose this angle here at C, which we don't know what its measure is, but we can look at the tangent ratio for this angle, which would be opposite to adjacent. 1 to 1.5 is the same as 2/3. Okay. Now, our first triangle had a tangent ratio of 2/3. This triangle has the same ratio, therefore it must be the same angle. So angle C must be 33.7 degrees as well. And that's what we concluded in question number 2, right? But we used a different argument. We said because we knew the triangles were similar, right, that their sides are just scale factor of 2. Okay. But now we can use the fact that they have the same ratio to argue that they would have the same angle measures. All right. Question number 3 wants us to find some sine ratios. Okay. Okay, so the sine of angle F is 0.5 repeating. But since F is 33.7 degrees, we could say that the sine ratio for any 33.7 degree triangle is equal to 0.5 repeating. All right, question number 4. Let's see, so we're looking at angle M here. And we can see that its tangent ratio would simplify to 2/3, right? 0.4 over 0.6 would also be 2/3. So we could write the tangent ratio for this mystery angle M is 2/3, which, hey, we've seen that ratio before. And because we've seen that ratio before, we know what angle we should expect to see, 33.7 degrees. So we could then argue that M must be the same angle as the previous triangles because it has the same tangent ratio. Okay. All right, question number 5. Okay. All right, we're looking for the measure of angle N, and we see that its sine ratio is 0.55. Okay. So the sine ratio of angle N is 0.55, and we've seen that ratio before. We saw it here and here, and so same ratio must be the same angle, which is 33.7 degrees. Okay. So N must be 33.7 degrees. So all these triangles so far, right, have been similar triangles. We've either shown it by finding the same ratio or finding some scale factor between the triangles. Yeah. All right, question number 6. Okay. All right, so the goal is to ultimately find the measure of angle X here. Now there's no measurements on the triangle, okay, but we are told that the tangent ratio with respect to angle X is 2/3. So let's write that. The tangent ratio for this mystery angle X is 2/3. Okay. Well, again, we've seen that tangent ratio before. We saw it here and we saw it here. Okay, and so it must be that the angle is 33.7 degrees. Okay, now we're going to write it a different way this time, right? So it turns out that there's a button on our calculator that you can tell the calculator the ratio, press this button, and then the calculator will tell you what the angle is. Okay. Now the button that I'm talking about is called the tangent inverse button, right? It says like tan to the -1. And so if we hit that button and input the ratio 2/3, then the calculator will tell us that the angle is 33.7 degrees. Okay, let me illustrate it for you using my my calculator on my iPad. You can try this out on the yellow calculator. Okay. First, make sure that your calculator is in degree mode. Okay. Now I'm going to look for the tan inverse button. What you're going to have to do is you're going to have to press the second key and then the tangent key to get to the tangent inverse function. Okay. All right, and then you can just type 2 divided by 3, 2 divided by 3, and then you can see over here on the right hand side of my screen it says 33.69, right? It's telling me the angle measure because I told the calculator what the ratio was. Right? So pretty cool stuff, right? If you know the ratio, tell the calculator and it'll tell you the angle. All right. So our last question wanted to know if angle J, right, was the same as angle X. Okay. Now we would argue that they're not the same because these triangles aren't similar. They have different ratios. The opposite to adjacent ratio is 18 to 10, which is not the same as the other triangle, right? It had a 2 to 3 tangent ratio. Okay. So this triangle is going to have some other measure. Okay. We don't have a similar triangle on the page to figure it out, so let's use our calculator. Okay. So we could say that angle J, right? We're going to use the tangent inverse button, sorry. And then we'll put in the ratio, which we know is 18 to 10. And then the calculator should tell us the angle measure. Okay. All right. Now, why am I using the tangent inverse button? Why not the sine inverse or the cosine inverse? Because the sides that we know are the opposite side and the adjacent side. So the ratio 18 to 10 is the tangent ratio, and that's why we're using the inverse tangent button. All right, so let's go ahead and try this out. You can follow along on your calculator. Tangent inverse, and then the ratio was 18 to 10. 18 to 10. All right, so it looks like the angle is 60.9 degrees. Right, which is entirely new. There wasn't any other triangle on this page that had that angle measure of 60.9 degrees. So there's no way we would have been able to find it out other than looking it up on our calculator. All right, so that's kind of the big takeaway from today, is that if you know the ratio, you can use your calculator to look up the angle. All right, let's go ahead and write this down in our quick notes. All right, so to determine the angle that goes with a given ratio, we're going to use the inverse trig keys on our calculator. Okay, so most handheld calculators, you're going to have to press the second button and then either the sine, cosine, or tangent button to get to the inverse keys. Okay. All right, so for instance, right, if we hit the sine inverse key and then we input a ratio, I don't even know what, I'm just going to make one up, a to b, right? Then the calculator will tell us the angle measure. Okay? Or we can hit the inverse cosine button, type in some ratio, a to b, and then the calculator will return the angle measure. Okay. The last option would be to hit the tangent inverse button, right? Input a tangent ratio, a to b, and get an angle back. Okay. So every time I write this fraction a to b, I'm saying, well, that's the ratio. And then every time I draw the theta symbol, I'm saying that's the angle. Okay, I guess we don't have to write it every single time. Just one time is fine. Okay, so long story short, after you press the right inverse trig key on the calculator, then you're going to input the ratio. So you type in a fraction, and then the answer the calculator gives back, we'll call that the output. Right, that answer is going to be the angle. All right, so here's an opportunity to pause the video and go ahead and try the check your understanding questions with your group. I think we should budget about, let's be conservative and let's budget 15 minutes. Okay, there's about 4 questions to do. Remember, number 3s are reading today. All right, so go ahead and pause the video, and then after 15 minutes, you can unpause and we'll go over the answers. Okay, so let's go over the answers. I forgot to make a key, so I'm just going to answer them on the fly here. Okay. All right, question number 1, find the value of the missing angle. So I can see that the angle is over here where the question mark is. 13 is the adjacent side, 18 is the hypotenuse. So we're looking at the cosine ratio, right? 13 to 18. Okay. So I'm going to hit the cosine inverse button on my calculator, type in the ratio 13 to 18, and that should give me the answer here. Let's do a split screen. Okay. All right, cosine inverse and 13 to 18. All right, so the angle measure there should be about 43.76 degrees. Okay. All right, next triangle. All right, so here's my angle over here. 22 would be the opposite side of my angle. 14 would be the adjacent side. Opposite to adjacent, hey, we know the tangent ratio is 22 to 14. Okay. So if we hit the tangent inverse button on our calculator, input the ratio 22 to 14, then what we should get back is the angle measure. Okay, so tan inverse 22 to 14. Right, so the angle measure is 57.5 degrees. All right, so that was question number 1. Question number 2, okay. If the sine ratio is 3 to 7, find the angle. Okay. Well, if they're just going to give us the ratio, then we'll use the sine inverse button to get the angle. All right, sine inverse. Okay, we know the ratio is 3 to 7. So let's go ahead and figure this out. Oops. Okay, so start a new line. Okay, sine inverse of the ratio 3 to 7. All right, so the mystery angle is 25.4 degrees. All right, so it doesn't get easier than that, right? If they're going to just hand us the ratio, then we'll take that ratio, input it into the calculator, get the angle. Okay, number 3, if the cosine ratio is 0.25, find the value of theta. Okay, well, this is like saying that the cosine ratio is 1 to 4, right? That fraction is the same as 0.25. Okay, so now let's use the inverse cosine function, type in the ratio, and we'll get the angle. Okay, inverse cosine, 1 to 4. Okay, so the mystery angle is 75.5 degrees. Okay. But what if I told you it was even easier than that? What if I told you you didn't even have to rewrite the ratio as a fraction, that you can just leave it as a decimal? Right, watch this. Okay, so I'm back on the calculator. Inverse cosine 0.25, right? You get the same answer, 75.5. Okay, so it's not even necessary for the ratio to be as a fraction. It could be in a decimal and things would still work out. All right, our last question, number 4. Solve the triangle by finding all missing sides and angles. Okay. Well, we're kind of on a roll here with the inverse trig, so let's stick with it. I'm going to find the angle W. Okay, so 4 is the side opposite to that. 7 is the hypotenuse of the triangle. So I basically know the sine ratio, right? The sine ratio is 4 to 7. Okay. So I'll go ahead and use my calculator and the inverse sine function, input the ratio 4 to 7, and I'll get the angle. Okay, inverse sine 4 to 7. Okay, the angle is 34.8. I'm just going to round that to 35 just to make my life easy. All right, so we know that this angle here is 35 degrees. Hey, we know that that angle is a right angle. It's 90 degrees. Should be pretty easy to find the last one, right? Here, let's change colors. Right, we know every triangle adds up to 180, minus 35, minus 90, and that should give us 55 degrees. Kind of did that in my head, but let's check. 180 minus 35 minus 90 is 55 degrees. Okay, so let's go ahead and write that in our image. Okay, so at this point we found all three angles, 35, 55, 90 degrees. We need to make sure that we find all the sides. We know 7, we know 4, we just don't know the last side. Okay. At this point, I would probably just use the Pythagorean formula, right? A squared plus B squared equals C squared. Right, let's call that A, let's call that B, let's call that C. Okay, A squared plus 4 squared equals 7 squared. Right, that'll be 16. That'll be 49. Okay, what is 49 minus 16? It's 33. A squared equals 33. All right, let's take a square root. Square root of 33, about 5.7. All right, so we did a lot of things on that last problem, right? We used a lot of different properties of triangles, right? We used some inverse trig, right? Took a ratio that we knew to get an angle we didn't know. We used the magic number for triangles, 180, okay? And we used the Pythagorean formula. Okay, so depending on how much time is left in class, what I would like to happen is to do an exit ticket, okay? Now there's 2 exit tickets. Let's say there's at least 10 minutes, go ahead and do both exit tickets. But if there's only 5 minutes, then go ahead and do the exit ticket that's about inverse trig functions.